Hello everyone. Today we are going to analyze this propped cantilever beam. In this beam there is a point load 24 kilonewton. It acts at a distance of 5 meter from the fixed end. The total length of the beam is 8 meter. In this beam we have different moment of inertias. For AC the moment of inertia is 2I and for CB it is I. Now from the point B and about the point A, we are going to find the movements and draw the bending moments diagrams. In this case, we have to follow left hand side rule. Clockwise will be negative and anti-clockwise will be positive. First, let us take RB. It is acting in the anti-clockwise direction and the distance is 8. RB into 8, it will be 8RB and the diagram will be in the shape of a triangle. Also, we can find the moment under the point load RB into 3, it will be 3RB. Now let us take the point load 24. It is acting in the clockwise direction so that it will be negative 24 into 5. It will be 120 and the diagram will be in the shape of a triangle. We know that in this beam the moment of inertia is different. For AC it is 2I and for CB it is I. So from the point C, we have to split this diagram into two parts. Let us keep this part as 1, this part as 2, and this diagram as 3. Using these, we can formulate this equation. First, let us take this triangle and find these two terms. Let us take this triangle and find area 1 upon EI. For a triangle, we know the formula to find the area half into BH. Here the breadth is 3 and the height is 3RB. For area 1 upon EI, we will get 4.5 RB upon EI. Let us find area 1 x1 bar upon EI. We have already found area 1 upon EI. Let us apply that. For this triangle, the centroid distance about the right is 2 upon 3 into B. Here the breadth is 3. So 2 upon 3 into 3. For area 1 x1 bar upon EI, we will get 9 RB upon EI. Now let us take this trapezoid. Let us take a trapezoid having the sides as A and B and having the length as L. The formula to find the area is L upon 2 into A plus B, and the formula to find the centroid distance about the right is L upon 3 into B plus 2A upon A plus B. Let us find area 2 upon EI. We know that here the moment of inertia is 2I. So instead of EI, we have to apply 2EI. Let us use this formula and find the area. L is 5, A is 8RB, and B is 3RB. Now let us find area 2 x bar 2 upon EI. We have already found area 2 upon EI. Let us apply that. Using this formula, we can find the centroid distance, but we are finding the centroid distance about the point B. So we have to add the remaining distance, that is 3. For area 2 x bar 2 upon EI, we will get 485 RB upon 6 EI. Now let us take this triangle and find area 3 x bar 3 upon EI. Let us find area 3 upon EI. We know that here the moment of inertia is 2I. So instead of EI, we have to apply 2EI. Using this formula, we can find the area. Here the breadth is 5 and the height is 120. For area 3 upon EI, we will get 150 upon EI. Let us find area 3 x bar 3 upon EI. We know the value of area 3 upon EI. Let us apply that. We know the formula to find the centroid distance about the right, that is 2 upon 3 into B. Here the breadth is 5. We have to add the remaining distance 3 also. For area 3 x bar 3 upon EI, we will get 950 upon EI. In this expression, we have found everything. Let us apply them. When we add these two, we will get this. Then we can eliminate EI. Finally, for RB, we will get 10.575 kilonewton. Now let us apply the rule sigma V is equal to 0 and find RA. Let us take a moment about A and find MA. RB is acting in the anticlockwise direction so that it will be positive and the distance is 8. The point load is acting in the clockwise direction so that it will be negative and the distance is 5. Let us assume that MA is acting in the anticlockwise direction so that it will be positive. For MA, we will get a positive value. That means our assumption is correct. It is acting in the anticlockwise direction. Here you can see the shear force diagram. To find the moment in the point A, we can use right hand side rule. In the point A, we have MA, which is acting in the anticlockwise direction, so that it will be negative. To find the moment in the point C, we can use left hand side rule. RB is acting in the anticlockwise direction, so that it will be positive and the distance is 3. For the bending moment at C, we will get 31.725. We know that the moment in the point B is 0. Here you can see the bending moment diagram. In this point, the moment becomes 0. This is the point of contraflexure. We can make a section in this point and find the distance. You can see that I have made a section in that point at a distance of x from the point A. We know that in this section the moment is 0. Using that concept, we can find x. Now we are going to end this session. Thank you for watching this video.